Welcome back. In the previous video, we talked about a few important questions that you need to ask when you're talking about your classes, right? So the first one is, what is the state? That means what are the member variables you need to have? And the second one is, how do you want to allow creation of a specific object? That is, what are the constructors that you would want to allow? Third one is, what is the behavior you would want to allow? That's basically the member methods. Let's consider an example, right? A ceiling fan. The fan here is not really a fan of a actor, actress, or a director. What we are talking about is a ceiling fan which gives you a little bit of wind, right? That's the fan we are talking about. So for this fan class, you can think about what are the different elements that represent the state of a specific fan object. You can think about how you want to allow construction of a fan object, and you can also think about the behavior, what kind of changes you would want to allow in the state of a fan class. You can pause the video in here. I have left out a few clues in here about how I think about it. Now, I would recommend you to pause the video in here and also think about how you would represent the state, what are the different constructors you would want to have, and what are the different behaviors that you would want to allow. You can pause the video here. Okay, let's start with the solution, right? So I said over here, I said the state I am looking at is make, radius, color, is on, and speed. So basically what we are doing in here is we are saying this is the manufacturer, this is the radius of a wing of a fan, and this is the color of the fan, and this is whether it's on or off, and if it's on, what is the speed. So those are the different things that are important to represent the state, but you might be thinking of a wide range of other stuff as well. Now let's try and represent the fan class in our code. What I'll do is I'll start creating a new project for this. So what I'll do is I'll say file, new project, and I'll call this oops advanced and say create, and I'll say open in new window and add to currently open projects. So we are creating a new project, oops advanced, and over here it takes a little while to create the setup and stuff. Hopefully it's ready very soon. Yep, here we go. We have it ready, and now I can go ahead and create a new Python file. I would want to call this fan, and okay, and let's now start thinking about this, right? So we said these are all the important things. Let me comment this out. So these are the different things that make up the state of the fan class, and these are, I think, the important things from a behavior. One of the important things that you need to take care of when you are designing the behavior of a class is think about the consumers. Think about who is going to use your class. Think about how they would like to see it. I think when we talk about a fan, the typical behavior is to be able to switch it on, switch it off, and also to be able to increase the speed and decrease the speed as well. So these are, I think, the typical behavior that might be expected by consumers who are going to use our APIs. Even when you're not really designing classes to be consumed by others, maybe consumed by yourself, even then I would recommend you to think about what kind of behavior you would want. Try and get a outside in perspective. Try and look at it from outside and look at how you'd want to design your class. All that theory aside, Python is all about getting things done as fast as possible. So try and keep this analysis to a bare minimum. Okay, enough talk, and let's get down to business. We want to create a class called fan. That's what we wanted to start off with, and let's create the constructor first, right? So when we are creating a fan, all that we would be able to decide is what is the make, what is the radius, and what is the color, right? So our constructor will represent that as well. So let's do that. Def underscore underscore init, and over here I would want to pass in make, radius, color, and let's do self dot make is equal to make, self dot radius is equal to radius, and self dot color is equal to color. We have our constructor ready. Make sure we have a colon in here, and now I'm ready to create an instance of the fan. So I'll do a print fan and pass the arguments that would be needed to create it. Let's say the manufacturer 1, and let's say the radius is 5 centimeters and the color is green. Let's run this and see what happens. Cool, it's printing the object, but it's cooler to print the representation of the object. So let's define the method representation as well. Representation of self, and I would say return representation of, inside that we have to create a tuple, and over here I would need to return self dot make, self dot radius, self dot color. Let's run this. Okay, cool. Manufacturer 1, 5 and green. That's cool. Now, one of the things that we can also do in the init is set the initial state for the other things, right? So we wanted to represent speed and whether it's on or off. I can set the initial state for them as well. So I can say self dot speed, initial speed is 0 and self dot is on. Initially it's off, right? So it's false. So in the representation also let's include that in. So self dot speed and self dot is on. Now if I run this right now, you'd see manufacturer 1, 5, green, 0 and false. Now let's go ahead and represent the behavior that we wanted to have for this specific class. Behavior we wanted to have are these 4 methods, right? Switch on, switch off and the other stuff. So def switch on. What do we want to do? We would want to say self dot is on is equal to true. One of the things is once fan is switched on, we would also need to set this state. This is kind of the business logic, right? So we are setting the fan to true and we are setting a default speed of 3. What we'll do now is we will actually do a refactor, right click, refactor and extract variable. This is one of the refactorings you can do, extract variable, and I'll give it a name of fan. So the object name is fan, and before printing it, what I want to do is I would want to say fan dot switch on. So by default at the start the fan is off. Now after switching on, what would be the state? Let's see what would be the result. So you can see that now speed is 3 and its on is true. Let's go ahead and define another function, switch off, right? So switch off, what we would need to do is on is equal to false. In addition to that, we would want to set the state to 0. So let's call this function and check if it's working fine. Fan dot switch off. Let's run this. Okay, cool. At this point, speed was 3 and switch on is true, and at this point, line 44, it's 0 and false. Now, I'll leave it as an exercise to implement the increase speed and the decrease speed methods. It should be very easy. All that you need to do is increment the speed and decrement the speed variables. In this step, we wanted to give a perspective on how you design your classes. What we think about is what are the different elements that make the state of the object, and think about what is the behavior you'd want to expose. Thinking outside in always helps because that would lead to better design. I'll see you in the next step. Until then, bye-bye.